I'm not going to put a lot of emphasis on exception handling, but there is a short discussion of it in Chapter 7. To motivate the discussion, they use the quadratic equation example, where it's easy to get a math domain error if you try and compute a negative square root, square root of a negative number. So here is the quadratic equation program. Um, this program prints the real solutions to a quadratic. Um, and you call this, I do this slightly different from the book. Rather than soliciting the input from the user, I'm supplying the inputs as parameters to the function a comma b comma c, where it's these are the coefficients to the quadratic equation ax squared plus bx plus c equals 0. So what you do with exception handling is you put the main code in here under a try, and if there's different kinds of errors, math domain errors for example, it'll go to different except statements, which, as the book explains, are much like if, else if, else if, else if, else statements. The last except is like an else. The first except is like an if. This is like an if else. Um, so um, one of the exception errors that you could flag down with this code is if you get math domain error, in which case you'd print no real roots. That might also this might also be triggered by not providing the right number of coefficients. It asks for 3 and perhaps 2 were provided. Um, this is a separate flag for that same kind of error. This is an error for the inputs not being numbers. Um, maybe your numbers were somehow not in the right form and something else went wrong. So this is just a catch-all. And so what I have here is a simple loop where I go through and I do 1, 2, 3, 4, 5 different assignments to A, B, and C. So if you look here, there's a list. I'm traversing the list. Each element of the list is a tuple. Tuple are these objects that are in parentheses, and so the first time through the loop, coefficient is 1 comma minus 1 comma minus 6, and then that gets assigned with the simultaneous assignment statements to A gets 1, B gets minus 1, and C gets minus 6. And that corresponds with this first situation that I have commented out here, where you have two unequal roots. In fact, you can see from here that you have minus 2 and 3 as being the two roots. The second one we would do would be 1 minus 4, 4, which would correspond to this second situation where you have two equal roots. The third situation, 1, 0, 5, would have no real roots. X squared plus 5 equals 0. There's no real value of x that can be negative, and in particular that can cancel out 5 to make a 0. Here we've missed putting 3 numbers in, and here we're putting strings in instead of numbers in. Okay, so let's run this, and the output is here, but let's just run it and you'll see what happens. Okay, so what happened here, if I can pop the interpreter back up again, is it correctly computes the first root. It correctly, which are unequal real roots. It correctly computes the second double root. It finds the third situation as having no real roots, but then when it gets to the fourth situation, it doesn't progress beyond that because um, there's not 3 inputs and only 2 are required. Again, I'm not going to make a big deal out of this. I think Zelli's explanation is rather cursory explanation, so that's part of the reason. Um, but anyway, it is one of the new things in this chapter that we're working on.